to start with, just with problem number 1. I'm going to write, I'll write a little bit on this page, but I'm also going to write a separate piece of paper just to keep it all straight so that you can see exactly what you're doing. So what is the area, I'm sorry that mine is so, I don't know why it's so fuzzy. What is the area of the largest rectangle that has its base on the x-axis and the other two vertices on the parabola y equals 6 minus x squared? So what is the area of the largest rectangle? So I'm maximizing area. Area of a rectangle is length times width, or we could say it's x times y. In this case, because my rectangle crosses over, so since this is the ordered pair xy, that means this square right here is xy. X times y would be the area of the square. So I want the rectangle. So my particular area would end up being 2x times y. Now remember, in order to maximize, we have to get it all in terms of one variable, but they gave us what my y value equals 6 minus x squared, so that's in terms of x. So I could rewrite my area instead of 2x times y, I'm going to rewrite it as 2x times 6 minus x squared. All right, so if I'm going to maximize something, I need the derivative. It'll be easier. I could use product rule, but I prefer to use power rule when I can. So I'm going to go ahead and distribute this. 2x times 6 is 12x. 2x times negative x squared would be negative 2x cubed. So if I take the derivative of this, that's going to be 12 minus 6x squared. Now I'm going to set that equal to 0 to find any critical points that I could maximize and minimize. So that would be 12 minus 6x squared equals 0. I'm just solving for x. So 12 equals 6x squared. I'm going to divide both sides by 6. And I get x squared equals 2. So if I take the square root of that, because obviously we're talking about area here, my x value is going to be positive square root of 2 because negative square root of 2. Well, I mean, I guess it could be negative square root of 2. It doesn't really matter. Obviously, it's both because it goes both directions. But now, that's not what it asks for, though. It asks for the area itself. So I found the x, but I have to actually plug it back into this formula to find my actual area. So it's going to be my 2 times my x. Actually, I'm going to plug it into this one. So it's all in terms of so that it's all in terms of x, since that's what I found. I don't know why I put square root of x. Square root of 2, sorry. 2 times the square root of 2 times 6 minus square root of 2 squared. Well, the square root of 2 squared is just 2. So that means now I have 2 times the square root of 2 and 6 minus 2. So that's 2 times the square root of 2 times 4, which is 8 square root of 2. So this one is A. 8 square root 2.